All right, in section 1C, what we're going to be doing is looking at sets and Venn diagrams. Now, before I go through any of the actual problems here and just talk about those things, what I wanted to do was briefly talk about Venn diagrams as you may have seen them before doing them in a math setting, which obviously we're doing here. In the past, the way that you may have been introduced to Venn diagrams would have been in a literature class or maybe in a science class. And what you would have seen were images of usually two circles that are overlapping each other, or possibly maybe three circles that are overlapping. And each of these circles would represent something that you're trying to break down and understand. So they could be like books in literature class. So this could be book number 1, this could be book number 2. And what you would do is just make a list of all the things that were unique to book number 2 in this area. You'd write down all the things that were unique to book number 1 in this area. But in the overlapped area, which maybe you want to draw it a little bit larger there, that information would be anything that these have in common. Now, that's how you would have done this maybe in a science and literature class. Our class is going to be a little bit different. You're still going to have some circles, okay? You'll still have the circles, but we're also going to be creating these boxes that go around them. We're going to call that a universe, and we'll see what that is a little bit. But the images can also change from what we see here. So you may see overlapping circles, but you might also see two circles that are not overlapping, that are just set within the box. And you can even get a third picture where you have one circle drawn a little bit smaller so that it can fit inside of the other one, and we call that subsets. All these things will be addressed in the activity. Okay, but a little bit different than what you saw in your literature classes, because we're not going to be making a list of information that goes in those circles. All right, so problems that we actually have here. The beginning portion of this is going to talk about the words not, and, or. Eventually we get to this if then statement, that you see a little later. I don't think it actually brings up the word not in this portion of it, so that'll kind of just find its way in when it's necessary a little bit later on. Okay, the beginning here is about how do we read things and we interpret. And sometimes the way we do things in a math class is a little bit different than how you do it in normal language, but you should be using what we know about general language to help answer some of these questions. All right, this is about the word and. Okay, the word and, you can see it there in bold print. All right, our statement says, to apply for a certain scholarship, the applicant must be a full-time student and be employed full-time. Okay, so we kind of think about what that means. If you're applying for the scholarship, what does that mean? You must be a full-time student and employed full-time. That means that there's two boxes that you need to be able to check off. You should be able to say, yes, I'm a full-time student, and you should be able to say, yes, I'm employed full-time. All right, so true or false. To be eligible for the scholarship, the applicant must meet both requirements. Yes, that's how we interpret it. Okay, an or statement. Let's see, our statement given here, to apply for a certain scholarship, the applicant must be a full-time student or employed full-time. So it's almost the same thing, right? One word is actually changed in this thing. We switch it from and to or. Okay, so then what that tells us is you don't need to meet both of these requirements. Like, this is how we read it in normal language. You don't have to meet these requirements. If you're a full-time student, sure, apply for the scholarship. If you're employed full-time, sure, apply for the scholarship. Okay, true or false? To be eligible for the scholarship, the applicant must meet both requirements. False. They can meet one or the other one. If they meet both of them, great, I guess. It shouldn't really change everything, I would assume, but they're allowed to apply if they meet just one of them. Okay, true or false? If the applicant meets both requirements, he may still apply for the scholarship. Yeah, of course you can, right? And then some of that is, think logically, like, oh, you're overqualified, so you're not allowed to apply for the scholarship. That really doesn't make sense in the context. Next, we're going to talk about inclusive versus exclusive here. Okay, this is where it gets a little bit tricky with the or statements. So or doesn't always mean it can be one or the other, and it could be both of them. Sometimes what it is you can be one or the other, but you can't be both. And again, a lot of this kind of comes across in our normal language. So just try not to pigeonhole everything here too, just to set strict rules here that we got. but be open-minded and really consider. Okay, this one says, you can pay me now or you can pay me later, right? You borrowed money from somebody. You can pay me now or you can pay me later. We're going to call that exclusive because you can either pay now or you're going to pay later, but you can't do both of them, right? And you go back to the scholarship, you can meet both of the requirements of the scholarship, and that's fine. But this wouldn't make sense to do both of these things because then you'd be paying twice as much. Okay, and we call that exclusive because it can't be the both. That stuff's written up here, by the way. Inclusive or, which implies that we can do one or the other or both. Or both. All right, next. A job description says applicants must have a high school diploma or 2 years experience. That one's going to be inclusive because if you meet both of the requirements, that's fine. All right, so inclusive, both is good. Exclusive, you're not going to do both of them. All right, so with some of the wording addressed, not completely covered because we're going to have to see how all the ends, the ors. We also have to talk about the nots and the if-thens as we go. So with it addressed, we're now going to start looking at like how to build a Venn diagram, how to draw pictures like this, okay? What we need to talk about first is, what is a set? So a set is a collection of individual objects. That can be people, that can be things, that can be ideas, can be whatever you need them to be. All right, but a set, they'll generally all go together for some reasoning. Like there's a way that you can title them and describe everything that's in that set together. All right, each of the items that are in the set will be called members. Okay. Oh, by the way, in case I forget to mention this a little bit later, hopefully I'll mention it several times here. A set, as we're looking at them here, there's a title that describes what they are. And you can either be in the set or not in the set. That's how this all works. You're either in the set or you're not in the set. So it's almost like a yes or a no that goes with each of these things. Okay, examples of sets. Oh, by the way, these are both the same set here. It said that somewhere along the lines. Other is equivalent. Set T, the set of US states that begin with the letter T. Okay, so you can actually describe a set just in the sentence. You can do that, and we can figure out what all those would be. You can also state a set using braces. Those sort of look like the parentheses and the brackets, but they got that little squiggle in the middle. These are called braces, and braces are supposed to be used just for set notation. Okay, so we can also describe this set as Texas and Tennessee because those happen to be the only two states that start with a T. All right, so you can usually see capital letters that are going to represent the different sets that we're using. Let's see, do we even come back to, nope, we don't come back to the Texas thing right now. All right, new problem here. A survey of 500 ACC students are asked whether they meet the full-time student status. In this case, the universe, okay, so the universe is going to be the overall group of things that we're looking at. Our universe is going to be 500 ACC students. They're asked a simple question, are you a full-time student? So we're creating a set now which represents full-time students, and you can either be full-time or you can not be full-time. Again, the other would be that you're part-time because you are at least a student. That's part of our universe here. Okay, so here's how the picture looks. The rectangle represents every object, every person, everything that we've got. Okay, that was the 500 ACC students that were asked. So all 500 ACC students are located somewhere within this box, so to speak. They're not actual real locations, but they can either be, they're in the box and they're either in the circle or outside the circle. So you get these two regions, region 1 and region 2. They're all ACC students, but to be within the circle, you also have to be a full-time student. So those who answered yes, I'm a full-time student will end up inside of that circle. The students who answer I am not a full-time student will be here, but they are all still part of the box. Okay, so this is about the box, the rectangle would have been called, the circles, and being located inside or outside of those boundaries that are there. Okay, so that first example was just a simple concept of a universe and a set and being in the set or out of the set. What we're going to do next is start looking at the different types of relationships that can be in these little sets. So you're going to notice we have two circles here. You're going to get those two circles that I mentioned previously where they overlap. And then later we're also going to see a third picture, which is going to be the little circle in the big circle in the rectangle, called subsets. All right, so these are called disjoint. We have a universe that contains two possible sets inside of it. Okay, and you can either be in the set or out of the set, in the set or out of the set. But it is impossible to be in both of these two sets at the same time. Okay, so let's see what we've got here. Universe, again, is ACC students. Okay, TE is going to be the set of students that were born in Texas. You were either born in Texas or you were not born in Texas. O is the set of students born in Ohio. You're either born in Ohio or you were not born in Ohio. Okay, why are these sets disjoint? Why can these not overlap? Because if they overlap, that's going to create a region that would represent students who were born in Texas and also in Ohio. That's going to make a little bit more sense when we start talking about the overlapping. So if you haven't done that part yet, then it's not going to make as much sense. But there's a chance that the circles can overlap, and that would mean that that student fits both of those sets. They're part of it, and this is impossible. It's impossible to be born in two states, I put in parentheses here, hundreds of miles apart, right? We didn't choose Texas and Oklahoma because we didn't want to get into the argument of being born on like a border sort of thing here. So let's just choose two states that are, you know, completely separated from each other, impossible to be born in both of those two states. All right, describing our regions within this circle, that being region 1 are students born in Texas. Within this circle are students born within Ohio. More interesting, region 3 are going to be all the students who were not born in either of those two states. Okay, which could be a lot, I guess. I mean, ACC majority will probably be in Texas, but you got the other 48 states here to consider. Okay, so next is overlapping sets. When the circles actually merge and you get this region in between them. So you get a fourth region, right? Because the other one had 3, now you've got a fourth regions here. Okay, this is going to be called overlapping sets. What they wrote here were they were sets that have some members in common. I put underneath this or could. All right, there's a chance that you might get what's called like an empty space, empty region where there's nobody who sits in there. But if it's possible that somebody could be, or something could be in the overlapped area, we just don't actually have that data on hand, then you should still draw these as a overlapping. So it's okay if we don't have any items in certain regions of things, but you want to consider if it's actually possible to. All right, so T is again born in Texas. Now M, totally different thing here, is going to be students who are multilingual, speak more than one language. All right, so those are things that could overlap. You probably know somebody, if you yourself don't already fit this category, that is a person who is born in Texas and speaks multiple languages. That's what region 3 is going to be. Somebody who fits both of these two types of things. Okay, now let me get back to circles and being in circles or out of circles. If you are inside of this circle, that means you were born in Texas. If you're outside of that circle, it means that you were not born in Texas. If you're in this circle, you speak multiple languages. If you're outside of that circle, then you only speak one language. Okay, so you can be in both of the circles, and that's what this region's for. Let me see if I'm pretty sure I've answered all this all right. Why are sets T and M overlapping? Because, as I said, you can do both. You can be in Texas and speak multiple languages. Region 1, oh, we're going to talk about those down here. All right, Region 1, students who are not born in Texas and are not multilingual. Okay, somebody from Nebraska who only speaks English could be in Region 1. Region 2, born in Texas but not multilingual. You're born in Texas, you're in that circle, but because you're not in Region 3, that means you only speak one language. Region 3, we talked about that one, that's where you're both. Region 4, multilingual, you're in this circle, but not born in Texas. So you can't be part of that region, so that's Region 4. Those tend to be the trickier ones that we see here because it's you fit one description, but you don't fit the other. But just keep in mind, you're either in a circle or you're outside the circle. If you're in the circle, then you fit whatever that description is. If you're outside of it, you want to say not. So there's that word showing up that was on the first page, not. All right, so let's see if we can identify particular spots, and we're also going to see that word not show up here. All right, so the first was done for us. It's the same situation we had with Texas and multilingual. All right, so they put a big bold X here, and they're talking about that region that's in the middle. You can state that as T and M. Okay, so we're going back to that and versus or sort of thing. So we're using the word and because you must meet both of the requirements to be there. All right, let's see. I want to find the or one. Okay, let's do this one next because I want to stick to more of like the affirmative things, the ones that say you do meet requirements. Okay, so I'm going to skip over to D. The set of students who were born in Texas, they are within the circle or speak more than one language in here. Almost sounds the same thing as what we got in that one, but the change of the words here, it says or. Okay, so that means you don't need to meet both requirements. You can be born in Texas or anybody in that circle. You could also be anybody who's in this circle. So you actually get all three regions. That simple change of the word now is not the overlap, but it's going to be all three of these parts. By the way, that is the inclusive, right? It's not just this one, and then you ignore the overlapped part, right? This is inclusive, and that tends to be how we see it in our math class settings here. All right, the other two that say no to certain categories, set of students who are born in Texas who speak only one language, so not multilingual. Okay, so they have to be born in Texas, so they're within that circle, but they can only speak one language, so they can't be part of that circle, which leaves you with that. Okay, and then you can write that as T, not M. Oh, and I didn't mention this one earlier, but it's T or M. All right, just make sure I say that one. All right, so if we have an X here, we've already talked about the overlap. We've also talked about all of those. What else are we gonna get? X just over there in M, so that will be multilingual, but not Texas. So M, not T, and it's gonna fit that description. Multilingual students who were not born in Texas. All right, then the next two here, I don't know if they're a little bit trickier or not. They're a bit more advanced, so it's good to have a sort of a break between D and E here. Okay, so they give you the description, different perspective. You're gonna write the statement that goes with it. Okay, not T or M. Okay, so notice the parentheses. That's important there. It says not T or M. So you have to think about what is T or M first. Now remember, we already did that one. T or M means it can be in either circle or in the overlap area. So it's all three of these spaces. But we want not that stuff. So that means it's going to be this one outside region, okay, where people were not born in Texas and not multilingual. Now, let me just kind of describe one. I don't want to write it, but let me describe it. If we take away the parentheses here, that one gets messy there, okay? But if we took them away, it would say not T or M. So it would be anything not in the T circle, which would be, I should just point this one here. It'd be anything not in the T circle, which would be this outside region and even over here. So really just those two, or M. So M is already kind of included here, but then that'll give you the overlap as well. So without the parentheses, it gets really messy. You can have not T, or it could be M. Okay, so really the only place you lose would be in this one spot, but you'd end up picking a total of three of them. I don't really see too many of those like written out, but I thought it'd be nice to elaborate on the reason why we have the parentheses and make sure that you don't just drop those off. Okay, F, not T. See, that one's a lot easier than this one. Not T, just anything not in that circle is fine. Here, fine. So you can be multilingual, but not in Texas. The best way to write it actually just fits this description here is we're not born in Texas. Okay, so it's regardless of whether you're multilingual or not. That part doesn't really matter if you're in the circle or not. They just said, don't be in T. They didn't say anything about M. They said, don't be in T. All right, next what we're going to do is talk about the if-then statements. Basically, where this is going to be your subset things, okay? An if-then statement, it's a logic argument of things that if blank, then blank. And it's almost like a cause and effect sort of situation. Whatever is in the if blank spot, let me just write that down. So you have if blank, then blank. If something is here, like it meets this requirement, then it automatically takes on that requirement that would be here. I think I'll kind of leave that hanging there, but it's if something meets one requirement, then it automatically is going to be the other one, and you'll see how that looks graphically. All right, heads up here. What we have you do is look at a Venn diagram, which is not a well-chosen Venn diagram. It doesn't really describe the situation as we would want it to here, okay? But we might be used to seeing overlapped Venn diagrams more often than anything else. All right, our universe. Always get that figured out. Your universe is domestic pets. Pets that people own, dogs, cats, birds, lizards, I don't know, guinea pigs, sugar gliders, chinchillas. All right, so, but we're gonna look at two little groups, which will be dogs and golden retrievers. Now, if you're thinking about the if-then stuff, we should make this acknowledgement that golden retrievers are dogs. Golden retrievers are dogs. Okay, so if we draw the Venn diagram as overlapping, and that sounds all right at first, because yes, golden retrievers are dogs. But it sounds funny if you say golden retrievers can be dogs. That part doesn't make sense. Okay, golden retrievers are dogs. All right, so region 1, these would be dogs other than golden retrievers. Okay, right? You can have a Yorkie, all right, Chihuahua, dogs other than golden retrievers, because it's just within the dog circle, but not in the golden retriever circle. All right, region 2, golden retrievers, and here's where it's weird. It's golden retrievers that are dogs. Well, they always are. So again, something kind of funny is going on here. They always are. Okay, region 3, golden retrievers that are not dogs. That's the big one right there. If you're in the circle, you're golden retrievers. If you're in that part of the circle, you are a dog. If you're in this circle, you're golden retriever, but in this region means that you're not inside the dog circle, so we definitely have a problem with how this picture is working. All right, region 4, not really any issues with that one. It's not dogs and not golden retrievers, so all your other animals, your chinchillas, they're over here. That's fine. But it's really that one, that region 3, that something's off with that one. All right, so which region is empty? It's 3. 3 is actually nothing. There's no such thing as a golden retriever that isn't a dog, okay? And the thing is that that's always going to be true, that you're never going to have anything that goes in that spot. So let me see if I can find what I want to look for. Previously, when I talked about overlapping, I said that you could have something in common. So that gives you the overlap. But could have something in common also leads that you could also not have something in common. And that's the issue that we run into here, is that you can't be a golden retriever and not be a dog. It just doesn't make sense. Okay, so how should we draw this? We should make sure that that piece doesn't exist at all, right? So pretend you just erased all of those lines, scribble that, and all that space really just sort of gets absorbed by region 4. So now you have a circle and you got this little section that's dedicated to golden retrievers within dogs. Picture doesn't look good though. This is a better way to draw it. Just actually take the golden retriever circle, shrink it down, and make it fit within the dog one. Okay, and you only end up with 3 regions. So region 1, I should add a little bit more to that. Dogs, but not golden retrievers. Okay, because region 1 isn't just anything that's inside this circle. It's anything in that circle, but also outside of this circle. So it's dogs, but not golden retrievers. R2 is going to be golden retrievers. They're all dogs, so that's why the whole circle is going to be sitting inside there. And then region 3 is just anything that would not be a dog. You're there. Okay, so this is called subsets. Now there it is. These are called subsets when one group is completely part of another one. And recall the if-then statements. If something meets this requirement, then it is going to meet another one. So if a pet is a golden retriever, then it is automatically a dog. It's a subset of that category. And I think that's what we address here at the end. If a pet is a golden retriever, then it is a dog. Okay, this is the really nice logic way of saying it in math courses. You can also state it this way, and it's fine. It just doesn't fit what we call an if-then statement. All golden retrievers are dogs. I think it might make more sense if you're not used to the if-then writing. Okay, but this is going to be the one that we want you to practice more because what is math? Math is a study of logic. It's a way to describe it, and this is a logic statement. This would be more of a everyday type statement that you see. Okay, so question number 9. This turns out to be a subsets problem, like directly what we were talking about beforehand. Universe is going to be written works. Okay, so I drew a picture of this, but I didn't label anything. So the universe is going to be written works, WW. All right, that's what we're going to have here. We have categories within fiction books and Harry Potter series. Okay, so each of these are going to have a circle. Each of those circles you can either be in or you can be out. You're either fiction or you're non-fiction. Harry Potter, it's either a Harry Potter book or it's not a Harry Potter book. All right, we'll use F and H conveniently to fit all of these. This is what we want to notice first. Harry Potter series is a subset of fiction because all Harry Potter books will be fiction. There is no non-fiction version of a Harry Potter book that exists. Okay, once we recognize that, see, here's where the questions are really going. We want to be able to give you this information and have you build your own Venn diagrams the appropriate way. Should it be disjoint? Should it be overlapping? Should it be subset? Or maybe it's just something different. Don't worry, we're not giving any of those, but there's stuff that does exist. All right, let's see. So we identify this as a subset because all of these have to be fiction books. So we should draw the picture like this. The subset is going to be the most inside. And then we have, so those are going to be your Harry Potter books. And this is going to be your fiction books. Okay, now a little bit of a difference in how I wrote this. I didn't identify these as region 1, region 2, region 3. Okay, what my letters are representing is what that circle represents. So when I put that F here, this represents that this circle is anything that is fiction, which also includes the Harry Potter books. So a little bit different than what we looked at before. I'm not describing like, so, and you can do this, but I'm not trying to describe this is just fiction. The little donut is fiction. Now, fiction carries all the way into that subset of there. Now, the donut itself, what it would represent would be a region that is for fiction books that are not Harry Potter. But I want to kind of distinguish that I'm not calling these regions. I'm trying to identify what the circle is. It's the title to the circles here. Let's see here. Your if-then statements. If it is a Harry Potter book, then it is fiction. Subsets, little circle, big circle. All right. So 10. This is also going to be a subset 1 because, well, it's an if-then statement. If you see anything that's an if-then statement, then it's trying to tell you this is a subset thing here. All right, so let's see what we got. If an animal is a whale, then it's a mammal. All right, so here's your subset because it's if whale, then mammal. Okay, so the whale is going to go in there. This circle is going to represent mammals. Here, I'll try and write it on the edge of the circle so it doesn't look like it's a region. And then don't forget your universe. What should our universe be? Animals. It says, if an animal is a whale, then it's a mammal. There you go. All right, 11. 11 and 12 do get a little bit tricky. I hope you tried them out, and then you can, again, if you haven't tried them out, please try them out and see what you can do, because even if you get them wrong, I just said they're tricky, but even if you get them wrong, because you've already attempted to do the problem, it's easier for you to understand the little weird things that I'm going to throw out here. All right, so our universe is going to be college graduates. Just put CG, so I'm going to write all that. College graduates. And what I figured out was important about that as I kept trying to make this a subset thing. That's what I was really aiming for here. I had to really think about what graduate students are. Okay, so graduate students, they're going to include males and females. It's also going to include all types of degrees. All right, your subgroups. So we're going to have circles for degrees in science, and I'll call that one S, of course. We're also going to have females with degrees. Okay, but notice females could have degrees in science. All right, so the question is it actually a subgroup? And for a bit, I sort of wanted to do that. I wanted to have a circle here. Let me draw it to the side. I wanted to have a circle that represented females with degrees, right? And then a subgroup of that to be S for degrees in science. But remember, our universe is college graduates, so it actually includes males that are in here. It includes males. And you can have males that get science degrees. Okay, so this is actually going to be an overlapping one. So you can have females, and you're also going to have science degrees. And each of these are something that we can identify who they are. Okay, so obviously this one's going to be females with degrees in science. Okay, these will be females with degrees that are not in science. And then anything that is outside of that circle are going to be male students who have degrees. And that region is going to be male students who have degrees in science. So it actually works better to be an overlap. A little bit of a sneaky problem here, but it works out better to let that be an overlap. And again, as I keep cycling back to this, you're either in the circle or you're outside of the circle, and they tend to be opposites of each other. I might not have addressed that part. So if these are going to be females with degrees, these are going to be males with degrees. Okay. Now, let me just kind of throw this out too, because there's like two things that go to that one, which is a little bit odd. Normally it's only one thing. Okay, everyone in the universe has a degree because these are college graduates. If you didn't graduate, you didn't get a degree in anything. So, so I think this little statement of degrees is kind of irrelevant because it's all part of the universe. So this is really about being females. Hence, we also called it F. Okay, 12. Also tricky. This is a tricky one to me here. Draw a Venn diagram that represents the following sets. Written works, WW. Fiction, nonfiction. All right. So I even did a little bit of research on this, and hopefully I'm absolutely right on this, but you can only be fiction or nonfiction. There is not another alternative. Okay, so, ideas that we sort of had to consider here. So this is going to be tricky. Subset is going to be out because fiction is not an example of nonfiction or vice versa, right? That's not a subset, it's out. Okay, we look at overlap. Can you be fiction and nonfiction? No, because, fiction means made up, nonfiction means that it's true. So it can't be an overlap. Then we have this other one, and this sounds like a good idea for a moment. Disjoint. And as I draw it here, it's perfect, actually. Disjoint, because you are either fiction or you are nonfiction. There's no overlap, Not a complete overlap, not shared overlap area, totally separate. But here's where it gets tricky is when we put it into our universe. If I go to put a box around it, I created a third region outside of the circles, right? Outside the circle. So what books are those? Or written works are they? Because the whole universe is written works. What type of a written work is either not fiction or is not fiction and not nonfiction? Because those are the only two choices. Okay, so this is an odd one. What you're really going to do, and I haven't looked at the official answer key that ACC provides for me, but here's my answer to it. We actually split our universe into fiction and nonfiction, and that's all you do, because you're either in one. All right, next, 3 circles put together. This might look a little bit complicated, but overall, from everything that we've done, it should go fairly smooth, and I don't think you'll really have any trouble with this if you understood the others. You can't do it with 4 circles. It gets too complicated to try and create all the overlaps, but you can go as far as like 3 of them, and each of the circles is going to represent some category that you're either in that category or you're not in that category, and different places that overlap or just what they are. Like region 2 is going to be things that will be S and E, but not C. Everything in the middle, of course, is going to be all of them, but I think that was more interesting to say. All right, so the S is going to refer to students, the E is going to refer to employed full-time, and C is going to refer to having children 18 years old or younger. All right, so the regions that had not been, well, they didn't label all of them there. Do we need to label the rest of them? We do. Okay. I guess I'll have to add that in there in a minute. All right, region 1, students, but not full-time, not children, is what it should say there. All right, region 3, the one we need to do, this is going to be full-time, fully employed, works full-time, but not a student and not children. Full-time job, but not full-time student and not children. Region 4 is going to be full-time student with children, but not inside of that circle, so not employed full-time. Full-time students with children, but not full-time job. All right, the others, I gotta label them. All right, full-time student, you're in that circle, who work full-time in that circle, and have, all right, so that's the all of them right there. All right, R6, students who work full-time, and so the whole universe is students, okay, but these are not full-time students. So I think that's what we're trying to get at. Students who work full-time and to have children 18 years younger. But not enrolled full-time. Duh, there's there. So this will be region 6. And region 8, 7 and 8. So 8's going to be not anything. Let's see what 7 is. I bet that's that one there. Not have children, not full-time, not, yeah. So that's region 8, which means this would be region 7. They got the kids, but they're not enrolled and they're not full-time working, or not enrolled full-time, not working full-time. Okay, overall, I think that's pretty easy once you've mastered the 2 overlapping. You just have a couple more regions. X's, where they go, part-time students, which means they are not within that circle. Works part-time, so not within that one, but do have kids. All right, Maya. All right, next, unemployed, not in that circle. Is not a parent, not in that circle. Is enrolled 15 credit hours. I had to go look that one up at the top. You need 12 to be a full-time student, so 15 is going to put you here. If there had been anything less than 12, that would just put you in this outside space from all of them. It's actually there. All right, 1C part 2. Yes, this is a long one. Not all the activities that we do are this long, but I know that this one is a long one. My personal opinion, I think it's kind of a fun one though, so hopefully you're enjoying it, but I think we're actually about halfway through, even though it's only part 2 yet. All right, what we look at here is adding in numbers. Okay, so part one was all just trying to understand what does each section represent. Now, we actually maybe get to take a survey of a certain number of people, like 100 ACC Northridge students, and you get to take that quantity of students and put them in the right boxes or right regions where they go. All right, so let's see. We're going back to Texas and multi-language stuff. All right, how many students were born in Texas and, so it's going to be an overlap, and speak more than one language? 11, got it. How many students were born in Texas? Does not mention anything about multilingual. So as long as they're in that circle, that's part of it. So we can get 40 and 11, which is 51. Okay, C, how many students were not born in Texas? From that, you could take the other two regions and you can add them together, which will give you 49. But you can also do another thing, because remember up at the top here, it says that 100 students were involved in this whole thing, and you should check to see all these numbers add up to 100. But if we figured out that 51 were born in Texas, then that means the rest of them, 100 minus 51, must give you those who were not born in Texas. So I think that was a really useful thing in how you can do the problem, or maybe how you can also just like check your work. And I know I show that, I show it right there, and it'll pop up in some other places as well. All right, D, how many students were born in Texas and speak only one language? That would mean you were in this circle, but not in this circle. All right, how many students were born in Texas and speak only one language? So you have to be in that circle, but you can't be in this one, so it's only gonna be the 40. E, how many students were born in Texas or speak more than one language? So that means you can be in either of the circles. You do not have to be in both of them, so you're gonna add up all of that together to get your value. But again, if you're adding all of that and the whole thing is worth, it says it right there again, 100, you can take 100 and just subtract the 31 to figure out what that total is, and that was 69. What I would do is probably the calculations twice, just from different perspectives, to make sure all the numbers are good, especially if you're trying to do mental math, which as a math teacher, I like doing mental math. I like to challenge myself with it, but I make mistakes. I don't know how often, 1 out of 20 times, maybe more often than that. All right, 2. We got a missing spot that we need to figure out here. Okay, grand total has to be 80. Yeah, you can probably figure it out just from there. All right, so if all this has to add up to 80, you can just, add all these together. You got 40, and then that'd be 55. Yeah, so if you took 80 and you minus 55, you're gonna end up with 25, which is that answer. Now, I answered a little bit different beforehand, but kind of thought about that from what I was just talking about. Where did I get my numbers from? 35 minus 10. Let's go back. Here's our 35. If 35 students are currently enrolled in a math course, that means this circle has to be 35. How many students work part-time? W is for working full-time, so we're just excluding that part there. They're math students, but not the 10 who work full-time, so 35 take away 10 and you'll get 25. All right, as a way to check my work though, what I did is I added everything up once I had that answer. I took the 4 numbers and I made sure that they added up to 80. If you did it by this method and you did it by that one, I think that would also sort of verify your work. Because again, you're taking the total and taking away what we already know. So just different perspectives, try doesn't really take that much effort to give it a couple of different approaches. But to guarantee you get right questions on the test, totally worth it. 3, okay, here's where it gets sneaky. And I did color code this a little bit so that help understand. These two end up being things that directly go into the picture. These two are things that you actually got to figure out. And here's why it's sneaky, is because you have 4 regions and you got 4 numbers. So you want to, the amateur at this, you want to put all those numbers just into certain spots, but they're very, very sneaky. Okay, so these are given to you, did not make an A and didn't do the homework. This is getting A's, this is doing all the homework, so that 12 would be on the outside. Notice that that number is larger than the rest of them, so they're trying to make a hint like you should do your homework and you'll do better in class. All right, 1, made an A, but didn't do all the homework. Okay, so you're in the A circle, but you don't get to be in the H circle, so that's where the 1 goes. Seems to fit. All right, next, 6 students. Added things together, total number of students who made an A on the first test. Okay, now notice something interesting about that, which is it doesn't mention anything about the homework. All it just says is you made an A, right? So we don't even need the word total. It could just be number of students who made an A on the first test. The thing is, it doesn't mention anything about homework, so that 6 has to represent that whole circle. So if you've already got the 1, then what we do is we take, knowing the whole thing is 6, you take 6, you subtract 1, and it gives you 5 in the overlapped region. All right, and then last clue, number of students who completed all the homework, regardless of whether they got an A, just completed the homework. So that means this circle has to be 7. If we've already found that this one's 5, then that one has to be 2, so they add up to give you 7. And one piece of information they did not give you, which would have been helpful to figure out if you were doing this wrong, is the total number of students that we had. So I'll go ahead and just add it up, because it's a reasonable question that you could get asked later. Just, hey, how many students were actually in this class? Let's see, that was 7, that's 8, so we get a total of 20. I don't think it mentioned that anywhere. No. Okay. Number 4. Okay, so here's what you want to do in number 4. You want to draw a Venn diagram. Okay, now I'm assuming that you already read it, so I don't want to read it word for word. This video is already probably long enough here. But it does fit an overlapping situation. You can be in an English course and you can be in a math course. Okay, you can be in both of them. So there is an overlap that exists. Okay, now the universe is 120. And where's my 20? Okay, 120, and it says that 20 students are enrolled in neither of these. So the 20 has to be the outside area. All right, and that's important because you can now take the 20 away from the 120 and know that all of this, all 3 of these regions has to equal 100. But if you go and add up 75 and 65, you get 140. And that's only 2 values, not 3. It's only 2 values, and you're already at 140 when it should only be worth 100. And that's because you have overlap. The way that it's described when they say 75 enrolled in math, that, let's say that that's math. That means this whole circle, this part and that part, is adding to 75. Okay, and then English, this part and that part. So within the 75 and the 65, there's some double counting on there. Okay, but let's go ahead and add them up to 140. And what's interesting is it tells you the overlap is the difference between these two. We have double counted 40 of the students. So 40, try and squeeze in there, is going to go in that spot. 40 students are actually taking both of them. Okay, and then if you subtract 40 from each of these numbers, you're going to get 35 and 25. And then this should all add up to being 120. I'll let you do that part, but it should all add to there. All right, the question they actually asked for was just to figure out that number, how many students were enrolled in both of them. But we could ask you any other question. We ask you, how many students were only enrolled in English? They could ask you that one too, and that answer is 25. Okay. The main thing about this is draw the picture. Everything's setting up for it. So when you finally come to the problem that doesn't have a picture, if you're not drawing one, then I think you're missing the point on why that problem's there. Which, by the way, every problem has a reason. Every problem is given to you for a particular reason, and that's what that one is for. All right, 5. Here's your 3 circles, lots of little regions in there. T is Texas born, M is multilingual, C is new category, traveled outside the country. All right, how many Texas born students are multilingual and have traveled outside the United States? So that's that complete overlap of 5. All right, how many students are multilingual? just have to be within that circle. Just have to be in there. And if you add all those up, you will get 100. C, how many students speak only one language? It's interesting, right? This is multilingual. So anything outside of that circle, boom, 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 all those have to be speak only one language. The approach I took at it was 300, and I subtracted what I already found, the 100, and that gave me 200. But you can double check the other way if you want to by just adding all four of the individuals. D, how many students are multilingual and, there's an overlap, and have traveled to another country? Okay, so T does not apply. We don't care about Texas, just multilingual and another country. These two circles, the overlap is the 5 and the 38, which would be 43. So the 5 are also Texas and 38 are not Texas born, but that's irrelevant, so we just add them together. All right, and then E, how many students are either multilingual or travel outside the country? So it's the overlap plus the 45 and the 12 and the 30 and 32. So anything within these two circles. What I think I did to answer it is I added up the two that were not included, subtracted those from 300. Okay, so you can do that however you want. All right, part 3, what we're gonna look at are two-way tables. In a way, two-way tables are a lot like the overlapping Venn diagrams. But in addition to the data that you're allowed to write with in the Venn diagrams, you're also going to be able to see the totals. Like if you had to add certain regions together, you're going to be able to get that here. Okay, so this two-way table, eventually you're going to draw these as Venn diagrams. So I'm going to try and talk about it, alluding to where we're going a little bit later. Okay, so survey is conducted and there's two questions that are asked. Do you own a cat? And that can be either yes or no. So in your Venn diagram, you're going to have a circle that's going to represent cat yes, and then outside of that would be cat no. But then there's a second question that's asked, do you own a dog? So you can either have a dog or not have a dog. But it is possible that people answered, yes, I have a cat, yes, I have a dog. That's going to be section A here, which is going to be an overlap between these two. Okay, so this would be that overlap. In fact, all four of the numbers that are right here in the middle, A, B, C, D, those are going to be those values that you always see in the Venn diagram. The E, F, G, and H are just going to give you some totals that'll be helpful. And then in this bottom corner, you're going to have like the grand total, the number that is your universe. All right, so we just talked about what each of these are. Section A is both cat and dog. Section B, cat, no dog. Cat, no dog. Section C, dog, no cat. D, neither of them. Nope, neither of them. Okay, and then E, that's going to represent a total. So you add across here is going to be A plus B gives you E. But what that then represents is just people who said they have cats. So regardless of whether or not they had a dog, these are people who had cats. F is going to be people who don't have a cat, right? Okay, then H says all the people who, so B plus D is going to give you H, and that would be all that don't have dogs. Okay, so for 3, we're now going to use some numbers and take a look at it. And again, I color-coded here just so that you could see like an order of how I do the problems. Okay, the blue is going to be everything that I can do like as a first step. I guess the best way to describe it here. Okay, so like this empty spot here, 8 plus 4 gives me 12. So I had both of those numbers, so I got the 12. 8 plus 12 gives me 20, so I had that. I can do some subtraction here. 10 minus 4 gives me 6, because 4 plus 6 will give you 10. Okay, so those are all things that I could do just as they are. These two values are more dependent on having learned more information. Okay, like 12 plus 6. So 6, I just wrote that one in. So now I can say 12 plus 6 gives me 18. And since I had the 12, I can say 12 plus 18 gives me 30. Or, this is where it's really cool, remember we found the 20 and we already had the 10, so 20 plus 10 is 30. So you should see in these tables that when you add these two and you add those two, they both end up with the same answer. So that's a nice way of checking your work. Now, as far as what goes in the Venn diagram, those are only going to be these values here. Okay, and usually what I try and do, if possible, is let the inside of a circle be like an affirmative yes, the outside to be no's. Okay, so these are both have dog and cat, which is 8, so that'll be the inside, like the overall overlap, because it's within both of the circles. The 6 is going to be no to either, so outside of both circles, there's a 6. And if you kind of keep that consistent where the affirmative is to be in the circle, these always go in those spots. The 8 will be the overlap and the 6 is going to be the outside. The other two values, you got to be real careful because it depends on like which circle matches the top, which circle matches like the side column. Just be real careful on that. So the 4 is going to be in the cat circle, not in the dog circle. In the cat circle, not in the dog circle. So that's where the 4 goes, and then the 12 will go in the other spot. All right, other questions that follow here. That goes straight to the Venn diagram, so that one should make sense to you. The others, that one goes straight to the Venn diagram. Okay, and then the others, I think it's more of needing to do some math here, but you'll find those values on the side of the two-way table as well. Okay, how many people do not have a cat? No cat is going to be 18. Now in the Venn diagram, that's going to be anything other than the 8 and the 12. Sorry, the 8 and the 4, which would be the 12 and the 6 that we already added. So there's kind of a neat comparison there that they match up. So it gives you 18. Question 7, how many have a dog? That'd be 20, 12 plus 8, but you also see it right here, have a dog. We did that one. Number 8, how many have a cat or a dog? That one's interesting because that one's a hard one to get from the two-way table, but it's super easy to get from here. Have a cat or a dog. Oh, actually, it's not as bad as I thought, but have a cat or a dog is just adding all of those together. But if you have a cat or a dog, then the only one we're excluding is the no here. So yeah, still the Venn diagram's a little bit easier to read from there. And by the way, instead of adding those, what I did is I subtracted a 6 as I had shown before. How many were surveyed overall? 30, which is the same thing as adding all of those together there. All right, question 11. The first part I like, the second part not too great of a fan of it, but it does make a point here. Okay, so good news. The table is completely filled in. These values are going to get added to the Venn diagram, and then we're not answering any questions after it. So hopefully the way it is drawn, the first column and the first row are going to represent the circles, right? So under 18, there it is, no claims right there. So not quite the affirmative as I said before, but we do have it matching the first column, which means that the 25 goes to the overlap, the 20 is going to go to the outside area. Check, check, you've got both of those. But you know, you want to make sure you are matching them up to the columns and the rows before you jump to that conclusion. These, just pay attention to what you're doing here. The 50 is the other spot that will be in the 18-year-old circle. So if I already got these filled in, the 50 has to go here. Then by default, 30 will go in that spot. All right, the second part of this says that, look, you can change how things are. You don't always have to use the first column and the first row to do it, though I think that's more convenient. So I didn't label any of the stuff here, I just put the numbers in, which is a little bit tricky on my end, but what I did is I got the 25 and the 50 in this circle. Okay, so if I go back and I look for the 25 and the 50, what they have in common is that they're the under 18. So I went with that same title for here, okay? But they were flip-flops, so how did that work out? Well, 50 and the 20, that's going to be these two. It's that second column, so that's at least one. At least one. Okay, and then with that, it throws off where things are because now the outside part is in that spot. Okay, so it's good to be aware that the order can be changed up, but if you're building your own Venn diagrams, let the first column and the first row be the circles, because then you can really just guarantee that's the overlap, that's the outside, and then these are pretty easy to figure out after that part. All right, questions 12, 13, and 14 are going to be the most involved here because you are going to have to make your two-way tables and you're also going to have to make your Venn diagrams. But remember, they're kind of the same data here, so it can't be too hard, right? Okay, so first we have in this one is a table that mostly complete. Again, the blue is the stuff I could do initially. I can add these two to get 21. I can add these to get 26. I can subtract to get the 12. I can gather all those numbers. Once I have those, and then I can add across to get the 27. I can add across to get the 48. And I can verify adding this direction to get the 48. Now, once you've figured out all of that, right, and it's complete, for the Venn diagram, the only number you really needed here was the 12, just to make sure that you did have that one. But there's other occasions where you need to know the rest for answering other problems in there. Okay, so I got everything filled in, but I didn't give them their titles. But remember, what I like to do is first column, first row. So look at 15 and 11. 15 and 11, those two, that's going to be the first column. So I had the column on the right before, but now it's on this side here. So this is going to be works, let's say 40 plus hours. Yeah. All right, 40 plus hours. Then we got the 10 and the 11. So if I use the first column, now I'm using the first row. So that is going to be moms. Okay. So by forcing that to be first column, first row, the 11 is going to be the overlap. The 12 is going to be the outside part. Check, check. You got half of that done. And then these, you just pay attention to what you're doing. The 10 has to be a mother. So you already have those two, and these are your empty spots here. So it has to be a mother, then put the 10 there. And you got it. And by the way, like depending on the category, some things are a little bit easier to read than others, like mom and father's. I think it just registers more than, say, more than 40 hours, less than 40 hours. It's confusing on that one. So try and use the easier ones when you can. All right, so 13, we do everything from scratch. Okay, doing everything from scratch. You got some clues here. Be very careful that you're not just putting all these numbers into each of those spots and doing it, right? You want to look for like where it all makes sense. And it might help to do the Venn diagram before the table. So we'll see as I go through it because I haven't actually done this one. All right, what do we have here? The only part that I did read is it's about having a high school diploma and not. It's also about having 2 years experience and not. Okay, all right, 32 applicants who don't have a high school diploma, we're in here, but do have 2 years experience. So that's what the 32 goes there. And you know what we're gonna do? We're gonna go ahead and start setting this up. So this is high school diploma. This is gonna be 2 years experience. Okay, so applicants who don't have a high school diploma, so they gotta be outside of that circle, but do have 2 years of experience. So that's gonna be in this, called crescent there, so 32. See how this all matches up. Okay, 2 applicants. Applicants who don't have a high school diploma and have less than 2 years of experience. No diploma, less than 2 right there. And that's gonna be our outside spot because you know how those match up. All right, 18 applicants who have both a high school diploma and experience. That would have been a great one to give you right at the beginning, right? Sometimes they hide the easier one somewhere else. All right, 45 applicants who have a high school diploma. Does not mention anything about experience. Has a high school diploma, 45. That means this whole circle is 45. So we want to subtract the 18 from 45. Subtract the 18 from the 45. 27. I hope I just did that right. Yeah, it sounds right. All right, 27 goes there, and you got your Venn diagram done. The rest of this is pretty easy to wrap up. You add across, you get 34. You add down, that's 50. That's 29. Across is going to be 79, which seems to match up. So we're all good. All right, 14. 14, basically doing this from scratch as well, so not much different than what we did there. Oh, except we'll answer some questions that go along with it. So we're going to build the table and the diagram based on this top part, and then we're going to answer these problems. All right, what we have is a medical trial for allergy medication, and they either get the medicine or placebo, fake pills. They either get improvement or they don't have improvement. So let's see what we've got here. A trial of new allergy medicine. 120 people were given the medicine and 80 people were given the placebo. Those two values have nothing to do with whether they saw improvement. So getting the medicine, 120 placebo, got 80. Probably should have done half and half, right? But that's how they set this up. Of those given the medicine, 90 showed improvement. So you have to be in that row under improvement, 90. So that means that this would be 30. We already got that one now. Of those given the placebo, 20 did not show improvement. Probably wouldn't. So then that gives you 60. All right, and then we'll check all our vertical adding here. It should work out fine though. 150, we get 50, and then you add that, you get 200, which was the same thing as the 120 and the 80. We'll move that into the table. We're gonna let this be med, because that's a row, and then second row is placebo, so outside. Improvement, and outside will be no improvement. So we get 90, you get 20. Medicine, no improvement, 30. Placebo, well, it doesn't matter, you know what it goes, 60. All right, questions to answer, and then we're done here. Oh, we did that. We did it, great. C, how many people who received the medicine? How many people who received the medicine did not see improvement? That was at 30 we had to solve for. And D, how many people who received the placebo saw improvement? 60. Oh, the mind playing tricks on you. All right, that was a super long one. I don't know how long it is because I'll have to add up the time later, but thanks for sticking in and going through all that with me.